The universe is a big place made up of many smaller important parts. If you zoom into it, you'll see the part that I want you to focus on for now, the inverse within this universe. The thing we'll be discussing right now is called inverse variation. The name makes it pretty clear. Inverse. That means opposite, right? In this case, when one quantity increases, the other decreases. You can observe this kind of variation all around you. An easy example is that if we increase the labor, then the number of days to complete the structure will decrease. Unless you hired the wrong people, but then it's entirely your fault and not the variations. Mathematically speaking, if one of the two quantities involved is y and the other is x, then this is how we show it. The proportionality symbol remains as it is, but the other quantity is placed in the denominator to represent the inverse effect. When we remove the proportionality symbol, we get an equals to sign along with k, which as usual can't be 0. Now, when it comes to solving a numerical, everything except the formula is pretty similar to direct variation. See this example for instance. An inverse relation of two variables is given. You know what to do with this information. Next, we are given the values of both variables involved, which will be used to get k, as we used to do before. As was the case in direct variation, here too, such questions generally ask us to find one variable for the given value of the other. Since mostly we have found the k by this point already, it is just a matter of putting it back along with the given value of the variable in the equation. That wasn't too hard, was it? Solve it then. Let's say this is equation 1 and this is 2. Now, in equation 2, if we substitute y with 8 and x with 4, the values given in the question, we get k equals 32. And putting this k along with x equal to 16 back in equation 1 gave us the desired value of y, which is 2. Can you spot the inverse proportionality? It's easy. When x increased, y decreased, and vice versa. Because your chances of making mistakes are inversely proportional to the amount of practice you get, here's another example question. Now, this time y varies inversely to the x squared, and these given values of y and x will help us to find k, the constant of variation, so that we can easily find the value of x when y is 100, the requirement of this question. Let's do it real quick. Replace, isolate, and substitute. Once you get k, we put it back in equation 1 along with y equals 100. 400 upon 100 is 4. But we want to find x. So, by taking the square root on both sides, we get the values of x as plus minus 2. But how does plus minus 2 satisfy the inverse variation here? Look, the square of either positive 2 or negative 2 is still 4. So, when y is increased from 16 to 100, x decreases from 25 to 4. That's it for variance. I can't add any new variance to the topic.